Hi guys, so today we are going to be going over area. We're all familiar with area. We've been doing it pretty much all year. You have done it before this year as well. So hopefully this should be things that you're all pretty familiar with. The answer key for last night's homework was posted on Google Classroom, so make sure you take a look at that. If you have any questions on that, of course, please feel free to send me an email and I will try to explain things a little more in depth if need be. So for today, the area of a figure is the number of square units that the figure encloses. The formulas for the areas of some common shapes include a parallelogram is base times height, triangle 1/2 base times height, a circle is pi r squared. You can use the parallelogram formula to find the area of a rectangle, but most of us are more familiar with just length times width. Area of a square is side squared, and area of a trapezoid is 1/2 height times B1 plus B2, and B1 and B2 stand for the two bases of the trapezoid. A composite figure we talked about yesterday with area, so we said that it is made up of two shapes joined together. And when we were doing perimeter yesterday, we said that we could find the perimeters of each of the shape and add them together. And we can do the same exact thing for area. Find the areas of each of the shapes and then add them together. A shaded region is sometimes used to show part of a figure's area. To find the area of a shaded region, you want to find the area of the larger shape that fully encloses it and then subtract any unshaded regions that are also enclosed. So the idea here is that you're going to find the area of the larger shape and subtract the area of the smaller shape. Okay. And then if you're asked to express the exact area in terms of pi, you are not going to calculate an approximation for pi. So if they say in terms of pi, that means that there should be a pi in your answer. Okay. So if we look at the first one, we have the key in a regulation size basketball court. So this is actually the same problem that we looked at yesterday when we were doing perimeter, except now instead of finding the perimeter, they want us to find the area, okay? So step one, determine the shapes being used. So just like yesterday, we said that it's made up of a rectangle, and a semicircle, okay. We want to find all the missing dimensions needed for area, and then we want to find the area of each shape in the diagram. So let's label this guy shape 1, which we know is a rectangle. And the area of a rectangle is length times width, which is going to be 19 times 12, which is going to be 228 feet squared. Our second figure is the semicircle. Okay, and so now the area of a circle is pi r squared, but because we only have half a circle, we're going to divide by 2, just like we did for perimeter. So this means we're going to have pi times the radius. So now imagine this guy is the diameter, which is 12. It's the same length as this side in the rectangle. So if the diameter is 12, that means that the radius is 6. So we have 6 squared divided by 2. And this is going to give us 18 pi feet squared. Step 4 is to add the areas. So we're going to take 228 plus 18 pi feet squared. And because they tell us to leave our answer in terms of pi, this would be our final answer. Okay. And then obviously you always want to make sure that you're rounding properly and including proper units. Your units should always be squared when you are calculating the area. Okay, for number 1 here, we have a circle and 2 semicircles are inscribed inside a 20-foot by 10-foot rectangle as shown. Find the shaded area in terms of pi. So, shaded region means that I want to find the area of the whole shape or the larger shape, which in this case is a rectangle, and I want to subtract out the areas of the parts that are not shaded, or in this case, the areas of the circles. Okay, so first thing, let's find the area of the rectangle. Which is length times width, and we have 20 times 10. So the area of the rectangle is 200 feet squared. Okay. When it comes now to finding the area of the circle, so they give us a circle and 2 semicircles. We said yesterday that 2 semicircles make up 1 full circle. So really this means that we have 2 full circles, which means that to find the area of the circle, we have 2 of them. Okay, so our area is going to be 2 times pi r squared, because now I have 2 of them. So instead of having half of them where we're dividing by 2, now I have 2 of them, so I want to multiply by 2. So we have 2 times pi times our radius squared. Okay, so here the radius, if this whole side here is 10, which acts as the diameter, that means that the radius has to be 5. Okay, and then 5 squared is 25, and 25 times 2 is going to be 50 feet squared. Oh, 50 pi feet squared, sorry. Don't forget your pi. 50 pi feet squared. Okay, and then they say find the area of the shaded region in terms of pi. So that means if I'm in terms of pi, there should be a pi in my answer. And then remember that when we're finding the area of a shaded region, we're doing the larger area minus the smaller area. So the area of the rectangle minus the area of the circle. So our area is going to be 200 minus 50 pi feet squared. Okay. For number 2, the diagram shows an isosceles right triangle inside a quarter circle with a radius of 4 centimeters. Find the area of the shaded section in terms of pi. So we have a quarter circle, and then we also have a triangle. So the whole shape here is the quarter circle, and then the unshaded part is the triangle. So I want to find the whole area here, so the area of the quarter circle, and subtract out the area of this triangle, and that's going to leave us with what we want. Okay, so the first thing, we're going to say that we have a quarter of a circle. And this means that the area is going to be pi r squared divided by 4. And they tell us that the radius is 4. So this is going to be, let's see, we have 16 pi divided by 4, so this is going to be 4 pi centimeters squared. Then the area of the triangle, we know that the area is 1/2 base times height. Okay. One thing we know that it is an isosceles right triangle, so that means that this side is congruent to this side, so this is 4 as well. So this means we have 1/2 4 times 4, and this is going to give us 8 centimeters squared. And now to find the area, I want to do the area of the quarter circle minus the area of the triangle. So our area, again, they say leave our answer in terms of pi. So we're going to have 4 pi minus 8 centimeters squared. I want you guys to try 3 and 4 for classwork. 3 and 4 is the only classwork that I'm assigning. Any of the extended practice is solely if you just want more practice on this. I'm not requiring it, but if you would like to try more examples of this, they're there for you. I will post an answer key for the extended practice tomorrow so that if you do want to try any of them, you have that answer key. So just these two, 3 and 4 for classwork, and then your homework is a worksheet as well, which is posted at the end of this lesson, okay? So it may say lesson 3, but it's really lesson 2. So this is your homework where it says homework, and then just 3 and 4 for classwork.